Hello, my name is Yang, and I'm a PhD student in William Mary. And today I'm going to introduce our paper for interactive bugger coding for Android app handling. This work is collaborated with the colleagues from the Johns Smith University and the University of Texas at Dallas. So when people find bugs when using a software system, they will use a edge tracker to record the problem. And so typically they will use the edge tracker is usually like a web form with several text fields and templates that asking for different information. But there's limitations about those systems. For example, they provide limited guidance on what elements need to be reported and how to report them. For example, this bug reporting system didn't provide the guidance on how to report the observed behavior, expected behavior, and step reproduce the bug. And another limitation is that they didn't provide the feedback. So on the quality of the information the user provided, so the user don't know the information they provided is correct or complete. So the interface is static, so that which puts the burden of providing high quality information on the users. To solve those limitations, we propose a BERT, interactive bug reporting system, and it has several features. First of all, it guides the user to report those essential elements like observed behavior, expected behavior, and step review. And it also checks the quality of those elements. And if there's a problem, it offers instant feedback about those problems. And it can also provide the graphical suggestions like the next possible step reproduce. So this is the whole architecture of the BERT. It is composed of several modules. And here is the graphical user interface, and the back end it also have several components. And these components interact with execution model. So I'm gonna start with the graphical user interface. As you can see, it has several parts. The main part is called chat box that allow user to interact with BERT. And the user can type the message here, and BERT process the messages and check the quality, and also provide graphical suggestions. And this panel lists all the step reviews that user provided. And there are also other several panels, but the idea is to facilitate the bug reporting process. And to check the quality of those elements and to perform the quality verification, BERT is the execution model. To build the execution model, we need to collect the execution data, and there are two methods. We collect the we use the automatic app exploration, and we also collect data from the app usage. Typically, it comes from people like the developers, testers, and users. And we use this data to build the execution database, which will process them to build the execution model, which is a directed graph. And in this graph, the nodes are the screens from the application, and the edges are the interactions. And after we get this execution model and the message from the user, and BERT tries to match this information with the execution model. Essentially, BERT tries to match the OB and EB distribution with the screens, which are the nodes in this graph, and match the step reproduce distribution to the interactions, which are the edges in this graph. And there are three possible outcomes. The first possible outcome is that BERT matches the screen and the interaction. And in this case, BERT asks the user to perform this if the match is correct. And the second second outcome is that when there's a multi-matches, and essentially that means the message is ambiguous. So in this case, Word asks the user to select one of them. And if there's no match, the Word will ask the user to replace and provide these elements. And the Word also provides graphical suggestions, like the next steps to use. At the given moment, that is based on the OB state, which corresponds to the observed behavior, and also the current state during the bubble coating process. And Word computes all the predict types from the current state to the OB state, and prioritize those types by the approach we defined. That is the shortest path using this formula. So that is essentially Word, and we divided the Word by implementing a user study, and we formulated, to evaluate Word, we formulated different research questions, like how the Word features useful, and how easy to use. How these Word features easy to use, and we also the quality of the bug reports compared with the one regular edge tracker, which is a web phone, like a GitHub edge tracker, and we call it iTrack. So for the study, we collect 12 bugs from different kinds, like functional bugs and crashes and graphical ones. And we also collect the videos for these bugs that illustrate how to reproduce the bugs. And these 12 bugs come from 6 Android apps of different fields. And we recruited 36 reporters to report bugs using Word and iTrack. And in the end, we collected 54 Word reports and 54 iTrack reports. In terms of results,
you want a professional photo, all right.
the reporters answered the questionnaire about the questions of how these features and the usefulness of the Word features. And from those pictures, we can see the screens that they found screen suggestions are useful. And they found Word can check the quality of the observed behavior, expected behavior, and the threat reviews they provided. And also they were able to understand Word messages. And they also gave the opinion about the panel of the separate views. So they found this panel is useful, and overall Word is easy to use. And about the quality of the bug reports, and we can see that Word leads to less incorrect and missing step reviews compared with Word, compared with iTrack. And the incorrect expected behavior is comparable between these two systems. And however, Word leads to more incorrect observed behavior. That means we need to improve the quality verification for observed behavior. In summary, we can see that Word leads to a higher quality self-reproduce than iTrack, and Word can correctly check those elements' quality. So, in conclusion, we propose Word, an interactive bug reporting system that aims to solve the limitations of current bug reporting systems. So Word can get the user unlike the current bug reporting systems, Word can get the user to report those essential elements and check the quality and provide instant feedback, including the textual and graphical feedback, and also provide graphical suggestions. So our vision is that our work is a paradigm shift from static to interactive bug reporting, and our work is a first step to achieving that vision.
Thank you so much, John.
Thank you.